Hi everyone, welcome to my YouTube channel. In this video series, we are planning to talk about the application of statistical methods in manufacturing industry. Please subscribe to this channel to get notified when a new video is released. In this video, we will be looking at normal distribution. The normal distribution is probably the most important distribution in both the theory and application of statistics. The normal distribution is specified by mean, Greek letter mu, and the standard deviation sigma. The visual appearance of normal distribution is symmetric and has a bell-shaped curve. The mean is the peak or center of the bell-shaped curve, and the standard deviation determines the spread of the distribution. Note that about 68% of the population values fall between the limits defined by the mean plus and minus 1 standard deviation, just 1 sigma. And about 95% of the values fall between the limits defined by mean plus and minus 2 standard deviations. 99.7% of population values fall within the limits defined by the mean plus and minus 3 standard deviations. It is common practice to round these percentages to 68, 95, and 90.7%. This is an important characteristic of normal distribution. If x is a normal random variable, then the probability distribution of x is defined as follows. Since the normal distribution is used so much that we frequently employ a special notation for that. And here's the notation. This graph shows a variety of distribution plotted by changing the mean and sigma values. When the mean is changed, the peak of the bell-shaped curve will be shifted to the left or right. And when the sigma changes, it will affect on a spread of the curve. Look at the mean value of 1 and different sigma values and see how changing the sigma will change the spread of the curve. The cumulative normal distribution is defined as the probability that the normal random variable x is less than or equal to some value a. This integral cannot be evaluated in closed form. However, by using the change of variable, the evaluation can be made independent of mu and sigma square. This transformation is usually called a standardization because it converts a normal random variable with mean mu and variance sigma square into normal random variable with mean 0 and variance 1. Mu is changed to 0 and sigma squared converted to 1. This is a special case of normal distribution, which is called a standard normal distribution or Z distribution. As we said, normal distribution is characterized by its mean and standard deviation. Both these values could get any numeric value. One of these possibilities is called a standard normal distribution or Z distribution, which has mean of 0 and a standard deviation of 1. A value on Z distribution represents the number of standard deviation. The data is above or below the mean. These are called z-scores or z-values. For example, z-value equal to 2 means we can fit distance of 2 sigma between the mean and this point. This is the formula to transform normal distribution x to the standard normal distribution z. Look at this example. The mu is 10 and the sigma value is 4. We can easily convert the normal distribution with these values to z distribution. Just plug in the mu and sigma in the transformation equation. Then you can easily find the z value or z-score for any value of x. For example, if x is equal to 10, the z-score is 0. And for x equal to 10.47, the z-value is 0.12. These z-value represent the number of standard deviation the data is above or below the mean. Then, to find the cumulative probability, we can use z-table. 0.12 is equal to 0.1 plus 0.02. Find those two numbers from this table. The intersection will be 0.47. This number will be cumulative probability calculated from z-table. We can utilize the symmetry property of normal distribution to evaluate some probabilities like this. Probability of x equal or greater than a is equal to total area under the PDF curve, which is 1, minus probability of x equal or less than a. The probability for x equal or greater than minus a is equal to the probability for x equal or less than a. Now let's look at two examples. We are going to solve these two examples in Minitab. The tensile strength of paper used to make grocery bags is an important quality characteristic. It is known that the strength is normally distributed with mean of 40 pounds per square inch and the standard deviation of 2 pounds per square inch, denoted by this. The customer of bags require them to have a strength of at least 35 pounds per square inch. So we need to calculate the probability that bags produced from this paper will meet or exceed the specification. Let's switch to Minitab. Go to Graph, and then Probability Distribution Plot, then select View Probabilities, then from drop-down menu, select Normal. Enter 40 for mean and 2 for sigma. Then go to the Shaded Area tab and select X value, and then select Right tail, since we are looking for a strength greater than 35 pounds per square inch. The shaded area to the right of the 35 pounds per square inch represent the fraction of bags exceed 35. So we would expect 99.38% of bags exceed the specification of 35 pounds per square inch. Let's do the example 2. The diameter of the metal shaft used in a disk drive unit is normally distributed with a mean of 0.2508 inches and the standard deviation of 0.0005 inches. The specifications on the shaft have been established as 0.25 plus minus 0.0015 inches. The question is, what fraction of shafts produced conform to specifications? So we need to look at these probability, which x is between 0.2485 and 0.2550. Go to Graph and then Probability Distribution Plots, then select View Probabilities. From drop-down menu, select Normal, and then enter the mean and sigma. Then go to the Shaded Area tab and select X value, and then select Middle. Because we are looking for diameter between two numbers. From the result, we would expect the process yield to be approximately 91.92%. Suppose that we can recenter the manufacturing process, perhaps by adjusting the machine, so that the process mean is exactly equal to the nominal value of 0.2500. From the result, 99.73% produced shaft conform to specifications. Let's switch to MATLAB and do some calculation there. Suppose you want to simulate some data using the normal distribution with a mean value of 2 and a standard deviation of 1. And here is the generated random numbers. We can find the probability distribution function with mean mu and a standard deviation sigma, evaluated at the values in x, and then plotted. We can also find the CDF of the normal distribution with the mean mu and the standard deviation sigma, evaluated at the values in x. There are other ways to create normal distribution in MATLAB. We can create a normal distribution object using the default parameters values, which are 1 for both mean and variance here. We can create a normal distribution object using mean of 2 and sigma of 1. Now we can create random number from that distribution object that we already created. Let's call it PD. Then we construct a histogram using 100 bins with a normal distribution fit. Let's compute the PDF values for the normal distribution at the values in x, defined between -5 and 6, with a step of 0.01, and plot the PDF function. We can also create a normal probability plot comparing the distribution of data in x to the normal distribution. The normal distribution has many useful properties. One of these is relative to linear combination of normally and independently distributed random variables. If x1, x2, and until xn are normally and independently distributed random variables with means of mu1, mu2 till n, and variance of sigma 1 square, sigma 2 square, and so on, then the distribution of y, which is the combination of different random variables, will be normal, with mean of this and variance of this. In this equation, a1, a2 until an are constant numbers. The Central Limit Theorem says if x1, x2 till xn are independent random variables with mean of mu I and variance of sigma I squared, and if y be equal to x1 plus x2 until xn, then this distribution will approach a distribution with mean of 0 and a standard deviation of 1 as n approaches infinity. The Central Limit Theorem implies that the sum of n independently distributed random variables is approximately normal, regardless of distribution of individual variables. It could be variables from gamma distribution, log normal, or exponential distributions. This approximation improves as n increases. We will discuss more about the Central Limit Theorem in other videos. Alright, this video covered an introduction to the normal distribution. If you like this video, please don't forget to subscribe to my channel and leave your comments below. We will continue to make such videos for you. Thank you. We are going to release video series on different topics including application of statistics in manufacturing and quality control, robotics and mechatronics, industrial machine vision, system dynamics, finite element analysis with abacus, GD&T and tolerance analysis, and many other interesting topics. Don't forget to subscribe to this YouTube channel to get notified when a new video on this topic is released.